Here we go. So I guess the first thing I want to say is logistical. Make sure that you are looking at that assignments tab on Zybooks to see what you got to do. All right. So when you go to an assignment, you click an assignment from like this chapter 1 assignment. It takes you to like a weird spot. Let me go through it the way you would do it. Like click load chapter 1 in a new window. And this is just the first section that I'm asking you to read. Okay, there's much more than that in the first assignment, and there's plenty of other assignments with other things in them. The way that you see exactly like what your current grade is, what you need to do is you go out to the table of contents, you like click the name of the book, and it should just take you to that assignment, which is nice. And for you on your end, you'll get to see your current score, like it's out of 51 points apparently, and like here are the sections I'm asking you to go through. All right, have we found that? So that's the secret there, and yeah, that's how that works. You can go back out to see all the other assignments too, and like, what am I asking you to do for chapter 2, etc., etc. I'll have to deal with whatever that exclamation point thing says soon. But there's that. And then also, because of the way that Zybooks and Canvas interact, there's a due date on the Zybooks website, and that's just the last day of instruction, that Friday that I told you can turn things in late by. That is not the due date for these assignments. It's just I had to put it to be that on the Zybooks website so it would keep transferring to Canvas even after the real due date. All right, Canvas is where the real due date is. All right, so you can find that probably in a few places, maybe the home, the calendar, or something like that. It's like coming up, chapter 1, August 20th. That's when it's really due. Okay, so hopefully you found all that. You got to trust the Canvas due dates, please. Okay, so there's that. That's Zybooks. Hopefully we found that already. And yeah, I want to start us off with a couple questions today just to get us in the mood for CSCI 41 stuff. So let's say that we've got this code. We just added this code to our big, wonderful industrial size project. Maybe this is inside of a method or a function. We added this if else, and you should always be a good software developer and write a test the second you write new code. So at a minimum, how many test cases do you guys think we should have for this code if there were like, there's something inside of these bodies, of course, but we don't know what. All right, so that is my question that I'm posing to you right now. Please, after you've done attendance, go to the by clicker page. Oh, did not mean to do that. And I'll start that. So yeah, get into little peer instruction groups, say hi to the people sitting next to you, and say hello, and please take a couple minutes to come up with your best answer for this and get it in. Convince your neighbors you're right.
Actually, I don't.
Is there a question? Lawtonslash.com. You can always get to it.
Yeah, I'm thinking. I'm logging in here, but I don't know my password for the Wi-Fi. You know how to like give your password like. Oh yeah.
Oh yeah, this is just business one.
So it's, I guess it's possible that it could be the first one, skip the second one, and then
Yes,
the ones two. Maybe it's been a minute. I had a long second.
Another minute. We'll come back. I ran over mine.
If something is solid, it's one. Else is else. Two. Or else. Three.
How many do we need to trust this code? Yay! All right, I hope that was enough time. Let's see what we're thinking. Boop. we are decently confident with the majority that it is C, but some of us want even more. I would say C is the right answer. Could somebody who picked C tell me their rationale? Yeah.
So there are three, kind of conditionals.
Yes.
So out of minimum three. So.
Good. Yeah. So does everybody see how like the way that an if-else is going to run, it has three bodies. It's only going to pick one, right? It's only going to pick one of these bodies to run based on these two conditions. Like either the first one hits, the second one hits, or they all fail and it goes to the else. So the program has essentially three new paths to go down. So I could go down this one, run that code, go down this one, run that code, go down this one, run that code. And I would say at a minimum, you should make sure that you have one test case that goes down each path to make sure that you implemented that path correctly. Okay, does that make sense? So I would say C. Obviously, you can definitely do more if there's more if-else's inside of here. So I don't know what that is, but at a bare minimum, I would say no less than 3. Okay, we good with that? All right, one more. So let's go back to the idea of like what takes longer than other ideas to implement. All right, so like let's pretend that we've written 2 programs. We've written a program that like takes a number from the user and then or it takes a bunch of numbers, n total, from the user and sums them all up. All right, let's say that we've already got them. They're ready to go and we just want to write the sum function that goes through like a vector and adds everything up. Okay, and that's option A. That's program A. Program B is, let's say we've written a program that's going to draw a box of stars of width n. All right, so like if n is 3, this would be the width 3 box that it would draw. So my question to you is, if n is large, we want size, or trying to sum a size 1 million vector of numbers, or we're trying to draw a box of stars of width 1 million and bigger, what's going to take longer to run on our computers? All right, can you think about that for a second? So I'll restart the question. Ponder that, all right? I'll give you a couple minutes. This one, there is no secret option that I'm tricking you. There really is a right answer.
Okay, this question I'm a little confused on because I don't know if it's like it's asking like it's summing n numbers. Maybe primers.
There's one blue.
So,
How we doing? Yeah, a decent amount of us have answered. I'll give you another 30 seconds or so, get a final answer in. All right, that's my timer. This time it didn't go off very loud, so that's nice. So, let's see what we're thinking. Ooh, okay, just a slight majority, but a decent majority is thinking B, and I would say that B is the right answer. All right, so let me try and explain the difference. All right, so if you're going to add up a bunch of numbers, let's say, I don't know, you got them in a vector, or you just want to like spell them out or something, and sum equals 0, like I want to add 1 plus 2 plus 3 plus dot 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 all the way up to n. Let's pretend they're ints or something. Like that's n numbers. Let's pretend we're adding those or something. Pretend there's 1,000,000 of them. How many pluses do we have to do? Yeah, or like 1,000,000 minus 1, maybe, I forget. I'd be off by 1. But like 1,000,000 minus 1 operations, right? 1,000,000 minus 1 pluses that the computer has to do, like pretend that the computer is just a giant calculator, types the 1, then the plus, then the 2, then the plus. Like it keeps on getting the answer and then building it up further. That's what we do with a loop, right? And then look at this box. How many stars total in the width 3 box? 9, right? If there was a width 4 box, it would be 16. What's the formula? It's n times n, or n squared, stars. So if you were like doing a loop, you would have to say see out a single star, in addition to like spacing issues. Not 1,000,000 times if it was 1,000,000 width box, but like 1,000,000 squared times. And that difference gets bigger and bigger. Just the n minus 1 pluses versus n squared C outs. As n gets large, I think you can imagine that graph. One is way overtaking the other. Yeah? Does that make sense? So that's where we're going in this class. All right? So any questions about that before I move on to more object-oriented programming stuff? So that is your future. All right? So I want to go back to OOP, object-oriented programming. We'll talk about constructors, just to make sure we're all happy with those. We'll talk about initializer lists, a weird feature of just C++, but useful. And my favorite example for going over classes and stuff about them is I would like to make a class that models this wonderful counting device, nice and tactile. We press the button and it increases the count. You can also reset the count by like spinning that wheel or something. But yeah, just imagine you wanted to make this in a program or something. You'll have a reason, right? Somewhere, some programs have to implement this kind of feature, right? It's like a hit counter on a website or something. Like how many people have visited this page? It's essentially you've made a counter class. All right, so that's what I want. I would like to make a virtual version of this. So I can make a type called counter and make as many objects of that type as I'd like counter C. And it exists, and I can talk to it. And I think the one piece of data that every counter should have is the number that's on the counter's window, right? So I'll call that count. Boop. And it will be set to 0 after we initialize it, right? We'll have a init like we did last time. We'll have inc to mean press the button to increment the count. We'll have reset to like 0 it out by spinning that wheel. We'll have get count to go and look at the window because it's not a physical thing anymore. We have to go ask it for its stuff because we're putting the count member variable as a private thing because we should not let the user access those, all right? So again, we have this init method just to make sure everything's happy because like if you didn't have that, like you declare your count member variable, it would start off as garbage otherwise. So we got to make sure it's set to 0, something normal when we unbox the counter for the first time. So yeah, let's make that in code. Boop. Oh, and by the way, can I stop attendance? Do we all do that? The next time I think about it, I'm going to stop it. All right. Let's see. Well, let's go to, I'll make just a file called counter. And let me pretend I have one. Here's like how I want to use like counter C. And then I'll be like c.init. And then I'll ask it to do some stuff. Like I want to increment the counter's count, c.inc a few times. I want to look at the counter's count now. If I inked it 3 times after initializing it, it should be 3, right? See how c.get count, so I want to use that. And then I want to be able to like reset the counter's count back to potentially 0 or something else. Like maybe we can have a reset method that takes like what we want it to be reset to. Like you can spin the wheel to like put it somewhere. It's like c.reset to make it exactly 42 or something. Spin that wheel to get it right there. Then if we were to increment that, we could put it, that would be 43, right? So that's the thing. Let's see. But yeah, so that should print 43, something like that. And I think that's good enough for now. All right, so that's what I want to have. So let's make that happen. So I like to make a class called counter. And it's got public methods and one private member variable. It's going to have int count. And then all of these bad boys are going to be public things that the user can ask us to do. Every counter, we can ask it to do these things. So let me turn these commas into there, semicolons, and then let's figure out what the types of these need to be. So we want init to just be void. We're just going to call it by itself, like just, here's how I'm using it. Oops. I'm using it down here like that. So it just takes nothing, does something to the counter, initializes the count. Inc, it's also just void, right? We call it, it does the thing. Reset, again, just void. But it does take something. Let's ask it to take like the new count that we want to put into the counter. We'll deal with that in a second. And then get count is finally going to return something. It's got to look at the count, give it back to the user. And this is how that's their window into our count member variable. We don't have like a set count. They cannot change it other than using it like init, inc, and reset. Okay, so that's what we want. And let's go and implement those things. Get rid of that. Scroll that down. So as usual, these look like functions in C++. We got to say no. I would like this to be the init method of the counter class. It's counter is init. Counter is inc, counter is reset, and then C++ is happy. It's like, oh, I see that you have a count member variable now. You can start talking about it. Beep. So all right, what does init need to do? Well, it better initialize that counter, right? Make sure that the count is set to 0. Inc should just do count ++, increment whatever the counter's count is. Reset should set the count to whatever new count should be, like whatever the user gave me. And then get count returns whatever our count member variable is, so the user can look at it but not change it. Okay, so I think that's the implementation. Are there any questions about any of that? Does it all make enough sense? So that's the declaration, implementation of those methods. We are forced to say init at the start just to make sure that that count member variable is zeroed out. Otherwise, it would be some random value, which is a little sad. So there's only one file, so just say G++ on it. Boop. And yeah, this is just a very complicated program that prints 3 and 43. Seems to work. Does that make enough sense? All right, do yell at me if you have any questions. But one thing I do want to show you that maybe you was just glossed over in a CSCI 40 class. I didn't really teach it in my CSCI 40 class. There's the idea of a default parameter. So if you go up to, usually it's the definition. You can only put it in one spot. You can put an equals sign next to a parameter. Be like, equals 0. Have we seen that before? Any of us remember reading about it in a book maybe? If you do this, that makes new count optional. So you did not have to give anything to reset. And if you did not give it anything to reset, you would still have a new count in the implementation in like the definition down here. But it would jump to this call with new count set to that default value of 0. So if I were to call it like this, it would reset it down to 0, and that would make 1 after that. That's pretty cool. It's called a default parameter. You can only put it in one spot. Usually you put it in the declaration. Because if you put it in 2 places, then like they could get out of sync, and then C++ complains. So they only allow it in one spot. So yeah, we'll do that. And so reset, it's like secretly 2 methods in one. It's one that takes something, one that doesn't take something, which is kind of cool. So there's that. Back to how it was. All right. And let's see, what are we unhappy about first? Yeah, we're unhappy about init. So I don't like having to remember to call init, because like if I were to forget to call init, I'm getting garbage as my answers. At least until I get here, because the reset's going to do something too, right? I should probably go run this on the server or something, because this local machine probably has the memory zeroed out. Oh no, good, perfect. Garbage. We have to always remember to initialize our things. So perfect. So we needed to call init. We cannot get around not calling init in some way. Like we need to initialize our counter. Okay, so there's a better way though, which is nice. There is the idea of a constructor. All right, so a constructor is a special method with a special name that it gets called for you. The second you make an object, you cannot forget it's called for you, one or the other. Like there could be multiple constructors, but it is called right after an object gets born in memory, and then it's going to initialize it. It's going to construct it. All right. So the name of a constructor is a little weird. It depends on your class's name. So a constructor is a special method with the same name as your class, and then there's also no return type because it's like implicitly void. It's like it's just building the thing, I guess. And that's where you want to initialize your stuff. All right. So I'm going to delete init and change it, essentially change it into a constructor. All right. And it will always be called for you. So let's see here. Dun, dun, dun. Yes, question.
We put this all down on our own class, on our own putty, right?
Can you repeat that? I couldn't quite hear it.
Copy this down on our own putty, correct?
Oh, if you would like to, I'm going to give you all this code, so you don't feel like you have to type every little thing down, because I do type kind of fast. I am not. Yeah, it's up to you. If you can follow, go for it. So let's see here. Yeah, constructor is something that gets called for. It's got the same name, so I'm going to turn a init into a constructor. It's going to be great. It's going to be a constructor, and so it doesn't have a return type. It's not called init anymore. It's called the same name as your class, counter. That's what it looks like. That's how you declare that a constructor, like we're making a constructor right now. And a constructor without any parameters, you can have constructors with parameters, is called the default constructor. If you don't choose another one, it's going to call this one for you. Default constructor. Okay? That's that one. Let me get rid of that real quick. So that's how you declare it. That's what a default constructor is. It's a constructor that requires no arguments. There can be other ones that do take arguments, and they're always going to get called for you, one or the other, either implicitly or explicitly. All right, so let's start with the default one for now. Do I want to do that? Yeah. So let me implement it. So it's essentially the init method. So it's counters, not init. It's counters counter. That's how you say it, right? Counters counter. Just like everything else, counter colon colon in front, but there's no return type. Okay, that's how you do it. Interesting. Let's also make a parameterized constructor, because maybe you want to these are going to get called when you build your object. So maybe you want to build an object, like what's something that we could give to a constructor that makes sense, just like maybe a starting value for the count rather than 0. Yeah. I guess you could get around this with doing the same kind of default parameter kind of things, but let me make 2 constructors. Counter, so that's a default constructor. You can also make, they're still called counter, and you can give it something. Starting count, let's say. All right, and that's called a parameterized constructor. It takes a parameter or an argument. Parameterized constructor. And this we can implement in essentially the same as reset. But it's a constructor, it's different. So we got that one, and it's counters counter method. It's counters constructor, parameterized constructor. And what should it do to the count? Set it to be that starting count that was passed. All right, so these are just methods. Now let me show you where they get called, because it's going to happen either explicitly or implicitly when you make an object. So here, oh, I did something bad. Let me restart my web browser. Sorry. Yeah. So here, there's the declaration, and then there's the implementation of the default one. Let me show you down in main where it's going to get called. So I'm going to delete this call to init because it doesn't exist anymore. And all right, if a constructor is something that gets called for me, when the object gets created, it therefore must happen on this line. All right, and so that's what's going on. I've made a constructor. I have not given any parameters or anything on this line, right? I just said counter C semicolon. So it's going to call the default constructor. Does that make a little bit of sense? I didn't say otherwise. That's what's getting called here. Okay, so this implicitly, right here, we just make the object, but you had a default constructor. This is implicitly calling, it implicitly calls the default constructor for us, which is wonderful. That's what we like. So that's beautiful. It's going to hit that code, and this entire program is going to work exactly the same, but now I can't mess up. I can't forget to call in it because it's part of the constructor now. Isn't that nice? Questions about that? It's this is where the object gets made. A constructor will be called if you made one. The default one is the one that's getting called here because we never like gave a value. We never like gave 5 or something. Like set it to that. Are you ready to see how to give a value as a parameter to a constructor? All right, so this is how you do it. Like somehow on a line like this, you got to give a number. It looks like this. You say counter, you got to like give it a name again, but instead of putting the semicolon immediately, you put parentheses. It's like you're calling the name of your object, 42. All right, because it took an int. That's where you put your parameters. So this one, that's kind of explicit now. It calls the parameterized constructor. And that's the secret. And now we can do stuff to C2, not C. And this should, if I were to print C2's get count, that should be 44. That's hitting the parameterized constructor. Beautiful. Does that make sense? Let me go and show you the declarations of those two. So again, they look like that. And then we implemented them like this. Ooh. Yeah, any questions about that? All right. So, there's a fun word that I want to teach you. It's a fun phrase. There is such a thing as a default constructor. Okay? Which is a little complicated. But if you did not give a default constructor, there still was one made for you. It just did nothing useful. Okay? There is such a thing as a default constructor. Like that. Like you put those words twice. And C++ will make a constructor for you if you did not make one, a default one. And what the default constructor does for you is it calls the default constructors of any of your member variables that are themselves classes, that are themselves objects. So for us, we did not have any like non-primitive type member variables. So the default constructor that we were using before we like if you didn't call init, for example, it was just doing nothing to count because that's not a class. It didn't have a constructor itself. But yeah, if we had a vector as a member variable, it would call the default constructor on the vector. And what does the default constructor on a vector do? Well, it's this one. Like it looks like this. That's what happens when you declare a vector v without anything. Immediately semicolon just makes it empty. That's what that does, right? Because vectors are classes. I think that's what I wanted to say about that. So that's a weird idea. We'll get back to that. All right, just you've heard it now. Next, I want to talk about initializer lists, which is a special feature of a constructor. This thing can only appear in a constructor, and it's necessary for calling non-default constructors of your member variables that are themselves objects. All right, so here's what it looks like. It's a little weird. So you've got your constructor. It's the same name of your class, right? Let's pretend this class name is blah. And you got some parameters. And then before the body, you give things that look like parameterized constructor calls, essentially. So we go back to this in main. That's a parameterized constructor call. That's what we're doing. You put a little semicolon after the parameters of your constructor, and then you start saying these names where these words right here are names of your member variables. I'm building this one with this explicit parameter. I'm building this one with this explicit parameter. If you omit something, it will be default constructed. All right? I promise these words will make sense eventually. I just have to say that. Okay? So, yeah, that's the beauty of that. And this is necessary. All right? I'm going to show you why in just a second. But constructors for your member variables need to be called here because by the time you hit the body of your constructor, all of your member variables have been made in memory and constructed somehow. If you omitted something here, like there was a vector v or something, we didn't say v, it was default constructed to be empty. Maybe you didn't want that. Maybe you wanted to fill construct it to hold like 142s or something. We'll deal with that, okay? But those are some words that won't make a lot of sense until an example. So let me give you an example, all right? And the hint is, the secret is, it's how you remember, it's got a little sad face right there. All right, that's how you find the initializer list. Okay, and you need this if you want to construct stuff in a weirder way. So let's say, just for fun, we still have count. Instead of having this implementation of the counter constructor, setting the count to 0 in the body, count is a member variable, and for a weird reason, you can make ints like this. You can say instead of int x equals 42, you can say int x parentheses 42, like it were a constructor call, even though it's just an int. Like it works for ints too. So like we can use that syntax. So instead of this, I can say it here. I can give my little colon, and I can say count, like the name of count. It's its name. Name of a member variable, parentheses. What do you want to call its constructor with? 0. And that will fill it in. You still need a body because it's an implementation, but now I can have an empty body because like I initialized my count in the initializer list. All right, that's how that works. So because I initialized everything in the initializer list, the body of the constructor can be empty. All right, that's beautiful. I could do the same thing for this one down here. So instead of setting count to starting count like this with an assignment statement, I can do it in the initializer list. Like, all right, count's the name of my member variable. I want to set it, I want to construct it to hold the starting count just like that. And again, I can have an empty body. And some people like to put just the parentheses or the curly braces on the same line just to signify that I did all my work for the constructor in the initializer list. Okay? It looks a little weird, but it's just setting count to 0 or count to starting count. So there's no real change. All right? Can we wrap our minds around that syntax? Does it make enough sense? If it's new? All right. And the reason you need this, the reason you need to know this, because like it looks kind of weird and silly. Like, why didn't you just use an assignment statement in the body for the count? You need this for a couple reasons. All right. You can the only way to construct your member variables in a non-default way is you got to use the initializer list, or if you have a const member variable, that's a possibility, and you want to set it to something different for different objects, then you got to set that const member variable in the initializer list. It's already been marked as read-only by the time you hit the body. Let me show that to you. So let's add, just for fun, we're going to add some silly member variables that we don't need. So I'm going to add a vector. I'll make a vector. Every counter is now going to have a vector inside of it. All right. And then we'll also have a const double called D. Okay. And so nothing really changes, except for, I mean, if I didn't have the double, like nothing needed to change. It would just be the vector V. But if you have a const member variable, remember that a const is something that cannot change eventually once you give it a starting value. I have not given it a starting value. The one place you can give it that value is in the initializer list. All right. So I have to say it here. D 3.14. It won't actually compile until I do this. If you see it underlining things, it's like uninitialized const member variable. It won't even let this thing compile. It's like you need to give it a value everywhere, and the only place you can give it a value is in the initializer list. It's too late if you try to do it down here, because like this is like an assignment statement on a const thing. You can't do it. That still won't compile. So you can only do it in the initializer list, if that makes sense. All right. That's kind of why you need this. I don't know. Let's set it to something different. And then it will compile. If you omit the name of a member variable in your initializer list, that one, if it's a class at least, if it's an object itself, and V is, it's getting default constructed. All right? I hope those words are making sense in our mind. So V is a vector. The default constructor on vectors builds that vector to start out as empty. All right? Default constructor called automatically unless you change that. And so let's change that by calling a different constructor on vectors. And I don't know if you've seen this. Let me just show it to you quickly. So the default constructor on vectors starts it out as empty. Dun, dun, dun. So these kinds of things, this kind of website, if you just search for C++ vector, if you haven't seen this yet, there's the default constructor. These names are here. All right, let me make this a little bit bigger for you. Doesn't actually need whatever this was because it has a default value. And then this one is called the fill constructor. You can give it a number and a value, two parameters, 2 arguments, and it will fill up the vector with this many copies of this value. All right, so let me show that to you. So let's do it for this one. For the parameterized constructor, let's call a different constructor on V. So like V, I'd like to build you as a vector holding 142s. We've seen that kind of syntax before. That's called the fill constructor on vectors. Again, it's too late in the body because the vector v already exists now. You can't be like v 142s, like you'd have to make a loop at that point. That doesn't work anymore. This is where you can hook into where that object is being built, the initializer list. Okay? So it's a little bit of a complicated idea, but it's necessary for those two reasons. If you want to hook into a constructor of one of your member variables, or you have something const that you need to set, you're forced to set it. And so by not talking about v in this default constructor, I did not say v's name, that means it got default constructed, all right? Because I don't mention the vector here, it gets default constructed, all right? This is what I meant by CSCI 41 is a little technical, all right? Any questions about that? Good? All right. So, I think that's most of what I wanted to say about this. So, all right, let me show you. Let me give you some screenshots, and I want you to try something, all right? Just like open up Notepad. You don't have to give me this, but I want you guys to attempt to write some code, at least for your neighbors, all right? So you can take out a piece of paper or something, but one way or another, write some code somewhere. You don't have to show me, but I want you to think about it, all right? So assume we've got this class. It represents the idea of a two-dimensional point where your x and y coordinates can only be integers, apparently. What I'd like you to do is make a declare and implement. So make a declaration here and like an implementation over here. Declare and implement a constructor for the point class so that I can make a point on a line like this, a parameterized constructor that sets the x and y to 3 and 5. Like you're giving that coordinate immediately on that same line. Does that idea make sense? That's what I want you to try to do. And I'm going to give you the parameterized constructor for counter so you can see it. So there's that. While you're looking at it, why did it give me two? Weird. And then there is this one, which is a little disgusting. Let me zoom out a little bit. Put it back all on the same line. That's the implementation and how we're using those initializer lists to do cool stuff. So I think I'll put it like that. Yeah, so please give that a try and let me know if you have any questions. We have plenty of time, so just shout out if you have any. But somewhere, at least for yourself and for your neighbors, talk about that. Try it. I'll give you 3 or 4 minutes. If you need to, do it the way without initializer lists and then add them in. But probably easier in your mind right now to set things in the body and convert it. Use initializer lists and set them up. I should do that, right? Yeah. Oh, thank you. Just a cough.
Awesome.
Question, yeah.
How do you open something on the on Buddy?
What do you mean open something?
Yeah.
You want to edit a file?
Yes.
So you say the name of the editor of your choice, and then you say the file name. Have you learned Vim yet? If not, you want to start with Nano and eventually do the Vim tutor. So you'll say Nano space, the name of the file you'd like to edit. Yeah, I'll come down there in just a second. I want to answer another question. SSHFS. I think. Quit. All right, another minute or so. So now, yeah, now you're in the wrong file. You already have one.
Is it? I don't know. Make sure. Oh, it's
To exit Nano, all the commands are down here. So character is Control X. So that's how you save the image. Line. This one. The original file. But if you did not get the file, it looks like you just set Nano without a file. Let's save. Save some.
It's like, how do I explain things to you?
That's a folder. You have to CD inside of that. Oh, yeah. CD space and you keep going. So, yeah. We can talk more about that during the lab. All right. So hopefully we all tried it. Some of you are on my written nice page. Okay, so we could have gone there. Did anybody submit to that? We can go look at it. Nice. Yeah. Maybe we'll do that next time. I didn't want to make things too complicated, but yeah, just for you guys. I also have this written nice page where we could have done all this stuff, but thank you. Maybe next time we'll do something like that. So yeah, it's looking good. You can get away with an empty body. When you implement a point constructor, you do not need the semicolon. It's just like a normal method, so you don't put semicolons after methods. Method implementation is just the declarations need the semicolon. So yeah, these are looking good. Thank you for that. Let me write it down too. So let's see here. To declare the parameterized constructor, you pretty much have only one option if you want X to come first and Y to come second, right? Point, that's what it's called, right? Same name as the class. And then it's int. You can call it xval, yval if you want, but you could also get away with, and this is another thing that the initializer list gives you the ability to do, you can get away with calling it x and y as well, which is kind of cool because there's no ambiguity when you use the initializer list, right? The first thing has to be a member variable name. It's not getting shadowed. I like that. So you'll see me do that in our labs. So the way that you can implement it then is outside the class is point, : point, int x, int y, and then colon to make the sad face, and then you say x member variable, set it to the x parameter because that's what gets precedence after that, comma y member variable, set it to y. So it looks a little weird, but if this looks too weird, you could have called this xval, yval, or something, and then it's less confusing. But yeah, the first thing is always the member variable's name, so it's not going to get shadowed or anything like that. But that should do it, something like that. Does that make sense? Questions about that?
Wait, so is the private X the one inside or outside the parentheses?
Yeah, so the member variables are the private ones. That's it's always the first thing you say. I want to set the X member variable to this thing. I want to set the Y member variable to whatever this thing is. Yeah. Other questions? All right, I think that's pretty good. So not too much more. Let's next talk about the word const in a weirder place. If you've never seen this, you can put const at the end of your methods. And what that does is it doesn't like make a constant variable somewhere, member variable that doesn't already exist. It marks the method itself as const, which means that it does not mess with any of your member variables. It's like it's a read-only kind of thing. No writing. Okay, so don't confuse this, by the way, with const parameters, because that's another thing. You have const reference parameters. We love those as well, but that makes sure that one variable, it does not get modified. If you put const at the end of your member function outside of any other like variable name or anything, it marks the entire method as const, and that means you cannot touch. You can only use all of your member variables, which is good because that makes sure you can't like mess with things that you shouldn't be messing with. So yeah, they keep you. It's a nice sanity check for you, the programmer, because we don't trust ourselves as programmers. They make sure that you cannot modify your own member variables for certain situations where you want that. All right. So yeah, the gold standard example of which method should be const is get count. Get count should just be looking at the count, giving it back. It should not be modifying anything at all. Yes? Are there any other methods that could be marked as const? Because what const means is it cannot touch the member variables. It can just look at them. You cannot mark a constructor. It makes no sense to mark as const because it's supposed to be setting things, right? Inc, again, it's supposed to be incrementing the count. It's messing with it. Same with reset. So it really is just get count. It's the only thing that we need to be const right now. And so you say it right there. It's weird. And then you also say it in the same spot in the implementation. It looks very odd the first time you see this, I can imagine. But the beauty of what this does, again, the program hasn't changed. It's not any different. But at the same time, it kind of is, because if we mess up, now we're going to get yelled at. So before, I could have said this. Count, you know what? You're going to be 42 now. The second I say const, this does not compile. It's like, nope, sorry. Const member function get count. It kind of marks the whole object as read-only for the duration of this method call, and this is not allowed anymore. That's wonderful. All right? So it won't even compile. That's how it should be. That's the beauty of const. So just to save yourself, the programmer, from having to worry about, oh man, did I accidentally mess with this? It's like the programmer's version of did I leave the oven on? Okay? That's how that should be. Every getter method should be const. That's a great example. All right? Questions about that? All right. So, just have a few assorted ideas left. I want to talk about pointers and classes and how they combine to one another. So let's say we've got an object. We've made counter C, we've messed with it, now the count is 2. Every object lives in memory, right? And so do the pieces inside, but like the object itself starts somewhere in memory. Let's say C starts at address 100, all right? You can for sure make a pointer to that address. And the type looks like this. If this is a counter, then I can hold the address of the counter by saying counter star. Give me the address of a counter, counter star. C2, and then have it hold the address of C itself. So that puts the 100 into another box, and C2 is just a pointer, okay? That's how that works. So yeah, counter star, remember that, because it's a pointer to a counter, and then it's holding the address of some actual counter somewhere in memory, all right? So now I want to use C2 to get at C, essentially. That would be nice. So the way we do that is as follows. Let me make a counter pointer somewhere. So we've got a couple counters. We've got C and C2 right now, so I got to make another counter star, I don't know, C pointer equals the address of C. So let's hold the address of C in C pointer. And let's say I want to go through this C pointer now to call get count and print out the count of the thing it's pointing to, which is C in this case. What I can't do is this. See out C pointer dot get count. Can anybody tell me why this won't work? It's not going to compile even. Any thoughts? Yeah, the type is not right. It's kind of conceptually, a pointer is just a number, right? I'm trying to say 100 dot get count, which makes no sense at all, right? I got to get to the actual object. I got to follow the pointer, get to the actual object. Then I have something I can call get count on, right? That's what we need. So you can do it in that order. Be like, all right, C pointer is pointing to a counter. Let me star that. Let me dereference to get to that counter object. Then I can call get count, right? That will, now I have the thing I can call get count on, right? That will work. But everybody decided that this is a lot of typing. You have to use the parentheses for precedence reasons. Everybody hates that, so they made an operator called the arrow operator that does both. So if you do arrow, like a dash and a greater than sign, it is both going to do the dereference and also get a member out. It's going to do the dereference and the dot all at once. And that's how you can follow the pointer and use a method or get out a member variable if it's like a struct or something. That's how that works. So I was happy now. Does that make enough sense? Like you can't just do the dot because it's just a number. Of all a pointer is, it's just a number. You got to get to the actual object that you were pointing to somehow. All right, I think that's what I wanted to say here. Does that picture make it clear? All right, so in general, we've learned a lot of ideas, right? I've tried to say them all. This is what you should be doing in your classes, best practices. So you should make all of your member variables private because we don't like when users mess with things accidentally. Like a counter should not be allowed to increment by 2 unless you call inc twice. Right? Don't just let the user say count plus equals 2 or something. That's not nice. So we will forbid that by hiding our count member variable behind the private modifier. Boop. And then you give access as needed. Let the user mess with the member variables with methods that do things that we want them to do. All right? And you can look at it, but you can't touch it in any other way. Okay? So that's called using getters and setters, like giving just the ones you want. Okay. Technically, we did give a setter for count. It was the reset. Technically, but like at least they had to type out what they wanted and make it obvious. So maybe that helps. I don't know. So there's that. You should next be sure to write constructors, right? You got to make sure that you have at least a default constructor every time you make a class that has like any sort of member variable that is like an int or a double, something that could be garbage potentially. If you wanted to like make a class with just a bunch of vectors inside of it and you wanted those all to start empty, then you didn't need that constructor because like the default one would have done that for you. That's okay. But if you want to do anything fancy at all, you better have at least a default constructor. All right. So we'll talk about that more as the class goes along. And then you don't trust yourself, so you make all of your methods const as much as you can. And then also you don't trust the user of the class that you're giving this to. And therefore, you're only going to make as few methods as possible to be public. You can make methods that are private, just for you, the implementer, like to save you some time. But only like what the user gets to do on your class is the public stuff. The fewer things you let them do, the harder it is to mess up using your class. All right, so forbid as many things as possible. And then, yeah, I talked about this in like the review video, the optional review video, like pass around references when you can, const references especially, to make sure you're not copying things a lot. Okay, so that's that. And then also just make sure to write a bunch of tests. I'm going to force you to write a bunch of tests in this class to make sure that all of your member functions are doing, all the public member functions at least, are doing the right thing from the perspective of the user. All right. So that, I think, is just like print that out, put it above your bed. All right. And that's what we want to care about in this class for object-oriented programming. And yeah, I think that is that. There's one more topic for the day. Are we ready for it? Let's go. I want to talk about operator overloading. It is a wonderful, wonderful thing. Some languages don't have it, like Java, for example. Java is horrible. We get to use this. So wouldn't it be nice? Maybe it doesn't work too well for a counter, but like just imagine you could make a class where this makes sense. All right, let's make a plus work for counters. That sounds cool. All right, so like I want to be able to do this, like C plus C2. That would be great. And be like counter C3 equals that. Does that idea make sense? Like to add two counters. now we have to decide what that means. What should happen? Like if this is C and this is C2 and they hold counts, like what should go on in C3? I think there's only one real logical thing to do here. Let's say this is this one, count is 2. This one, count is 3. Then C3 that just got made from the addition of the two counters. Let's say that probably its count should hold 5. Yeah, the sum of the counts. That makes sense. Imagine you made a type where it would make even more sense for plus, like I don't know, complex number type or something. I don't know, something like that. But we can want to do this, and we can have this syntax work. That's what we'd like. All right, we can make that make sense to C++. So we can have this code do its thing. Counter C3 equals C plus C2. But right now it's not happy. Right now it's not going to compile. It's going to complain and be like, it's going to give you a very disgusting error message, actually. This is one of the unfortunate facts of C++. It's going to be like, you tried to add two things, and I didn't know how to add them. You didn't tell me how. And the way C++ complains about that is it says, it thinks it's being helpful. It's listing out all the ways it knows how to add things. That's what it's doing. That's why this error message is so long. Like, I know how to add two ints, I know how to add two doubles, etc., etc. I did not know how to add the two counters. So that's what I saw on both sides of the plus. So, okay, we can tell it how. We can give it meaning. We can give meaning to that plus on counters. That's all we have to do, all right? And the secret is, this gets a special name. It's not just plus, like plus parentheses or something, like as a function implementation or as a method implementation. The full name, it's getting translated under the hood, all right? It's getting translated under the hood into the word operator plus whatever that operation was. So really the plus operation, as far as C++ is concerned, it's really called this. It's called operator plus sign. That is a plus sign, not a T. Operator plus sign, and that's why you see this in the error message. Operator plus. That's what we have to implement. That's the name, and like the plus turns into a call to operator plus. Okay, so operators have this name, and they could either be C++ is going to go looking for either a function called that or a method called that took the correct types, that took two counters somehow. If it's just a method only, it's the one thing. But let's say, for example, we wanted this to turn into something with operator plus. Let's turn it into a method, all right? So C++ would go and try to call either C.operator plus. I don't know if that's very legible. C.operator plus on C2, or it will go looking for a function called operator plus, if I can spell operator plus, on C and C2. Then it took them both like that. So either, somehow it's getting two counters, either as a method call or as a function call. Go looking for both of those. You can't have both, otherwise it'll get confused. But you make one of them, and it will turn into that call. Does that make a little bit of sense? That's what I'm about to show you. So you have options. You can make it a method call, or if these two things are objects at least. If the first thing is an object, then it's fine. Or you can make it a function call. So let me spell that out here too as well. So when you say C plus C2, the compiler tries to call operator plus C and C2, or C dot operator plus with just C2, because like you got the first thing as the object you're calling the method on. So either one is fine. Let's make this operator as a method call. So let's have this be secretly translated into C.operator plus on C2. All right, so we got to go make that. It'll be a method in the class of whatever C is, which is counter. So let's go up into counter and implement that special method. So it will be boop, operator plus. It takes another counter, and so following my rules, I would like to look at the count of another counter. I do not want to mess with the count of another counter. Just the fact that I'm getting another counter, I should be taking it by reference first of all, the other counter. And then also because I just want to look at it, I'll make it a const reference to that counter. All right, operator plus, and it's going to return back a third counter. It's got me, the thing I got called on, the other counter that I'm adding it myself into, and then this is the type that I'm giving back. I want to give back a brand new counter. right? And then also I'm building up a bigger counter, a final counter to return. I'm using my own count and the other's count to build up a third count. I'm not actually touching any of my member variables. I'm just looking at them, aren't I? So this is a const method. Should be, at least. So that's what you got to say, at least following all our rules. And then we can implement it. We can give meaning to plus. Boop. So it's counters operator plus method. Cool. And what do we want to do? We would like to remember what got us here, I guess. It's like, this is called, when somebody said like this, which turned into c dot operator plus c2. So we got ourselves, our own count, and we got the other things count. We want to add them together. That's our goal right now. Called when we're supposed to add our count with other.count. All right. Why did I put 2 spaces there? I will never know. So what I want to do is return a third counter like res or something. And then what should the count be inside of that result counter? I'll eventually return that. It's like res.count equals my count right now plus others count. All right. And so I am being a little lazy because this is like, I'm default constructing this. I could have used the parameterized constructor with this exact value, but it's fine. And also I'm within the class, so I'm allowed to touch my member variables of a third counter. It's still the counter class. So that gives meaning to plus. It will go looking for this now. I guess I can't do the normal split screen. I have to do this split screen if you want to see it. And here's the call. And, well, let's print out the count. Because it's just another counter at the end of the day. We apparently, I think one was 43, one was 44. And so it's the summed count is going into C3, and that's 87. Cool. Any questions about that? Is that making a little bit of sense? That's useful. It's like, this is so much cooler than saying like C dot add yourself to C2, because that's what you're forced to do in Java. You cannot do anything like this. That doesn't look as nice. We like the plus sign. Boop. All right. What else do I want to do? Let's also make a multiplication operator to multiply the counts, I guess, in the counters. Why not? So again, we could make it inside the class or outside the class. Let's do this one outside the class so you can see that other option. It's just like, it would get called like this operator star with 2 things. The 2 things you put on both sides of the star. All right. And that should be what I wanted to say. Yeah. So let's try that. Not too much going on here. Well, let's pretend we have it first. It's always useful. I will say counter C4 equals C times C2. And this one, I want to make it this way. This one should call operator star the function on C and C2. Okay, that's what I want to have happen. And then I can print C4's get count. Boop. And so if I want this to be a function, it's got to look like this, operator star, and it's taking 2 counters and giving back a third counter. All right. So it's just a function, so it'll look a little different than this one. So still give back a counter. Its name is not part of any class. It's just a function. It's called operator star. Still takes it takes 2 counters now. It takes the first one on the left side of the star and then the one on the right side. So we got const, counter, reference, like A and B or something now. So we need them both. If it's a function, we have to have both sides. All right. And I guess there are 2 ways to do this. If we want to do it in the same way, this is like option 1. We want to do it in the same way that we were doing the plus operation and mess with member variables, then if this is just a function, we have to mark it as a friend, don't we? Oh, sorry, const doesn't make sense as a function. That's only for methods. So this won't compile right now because I'm going into member variables and this is just a function. Yeah. If I want it to work, I can make it a friend. Like you can make the operator a friend because then it can do the dot. It can do the right thing. So like we trust this operator star function. So I can say that. Something like that. And I say friend. That thing. All right. And now it's happy. Now I'm allowed to touch member variables and it'll all be okay. And I'm supposed to multiply them, aren't I? and it's also called A's count and B's count as well. All right, but now I can go into them and get the right stuff out because I marked it as a friend. Otherwise, I would not be allowed to do this because those were private things. So what's 43 times 44? I assume it's that. All right, that's the answer. Does that make sense? So I called the thing. And this time I gave the function version and hit that one. It turned into this call, did the right thing, gave back the counter, and now I can use that new counter that it gave me. You good with that? All right, you do have another option. If you don't want to mark it as a friend, there's still a way to get counts out, aren't there? I could have said, this could be option 2. I could say, I don't know, I got to make a new counter, and I got to give it a count, don't I? I've got to give it a count, like, and then return that result counter. Well, if I comment these out, I can do the right stuff still with the public things. To set, I could use .reset to set, or I could use the parameterized constructor to set the counters count. And then to get the counts of A and B, there's a getter for that. A.getCount. So I didn't have to mark this as a friend times B.getCount. Does that make sense? I could have done it this way. And then it didn't have to be a friend. I'm using public things only. It'll still work. That's option 2. Yay. So it doesn't always have to be a friend, but sometimes it makes things easier just to have that full control. All right, and yeah, that's most of the story. There's other operators, right, where that came from. There's plenty of pages with lists of them. Like, look at all these bad boys. You can implement all of these. Star, remainder operation. You can override what it means to assign one thing to another. And we're going to do that later in this class. What does it mean for one thing to be less than another? You can override the plus equals operator, the plus plus operator, the and the or. Why not? You know what some of these have to return, right? The and better return a bool, right? It's taking 2 of something and better give back something true or false. So you're kind of forced for some of these things, but for others, like you could decide, like, all right, %sign is going to return a counter. Sure. You can do all that. Okay. So scroll down and find more of those, but that's kind of fun. The last thing I want to do is a very special operator that we're going to use a lot. I would like to make an output operator, which is this thing. It's this thing that we give stuff to see out with. I would like to use that to be able to do this, because it's a little clunky right now. If I'm trying to print counters, I'm printing their get count call, more or less. Wouldn't it be nice, again, if I could say this, see out, hey, see out, just take the counter. Take the counter, print that thing. Does that make sense? Yeah. That's what I want. Again, I have to give meaning to this, because see out has no clue what's going on. And by the way, this is an operator, so what does that mean I need to implement now? What is this going to get turned into? I don't have access to the implementation. I'm like, see out is an object, actually. I don't have the access to the standard library implementation. I can't go and edit that. So I'm forced to make this as a function operator. So it's called operator less than, and it's getting called with cout and this other thing, counters. That's what this will turn into. If I give meaning to that and implement it with the right types, I can make this line work. That's pretty cool. I can say what it means once and for all to print out a counter just by itself. All right? And so here's what the types have to be when you implement this operator. So its name is operator less than. You put your own thing second, right? Because it's like cout first, the other thing second. And then you have to give, well, cout is just an object. It has a type. The type of cout is called an O-stream. Okay? It's called an O-stream. And we're taking it by reference because there should only ever be one cout. We're not copying any couts. Okay? And then also it's not a const reference because we're messing with the content of the terminal screen. And cout is like the terminal screen. We're changing it. So it's not const anymore. We take it. That's cout's type. And I can prove that to you. It's an input-output. It lives in IOStream. Cout, click on it. Its type is OStream. That's the type of cout. You can click on that. That's what it means to be an OStream. You have these options. All of these operations exist for you. All right, including that less than output thing. Okay. And then, instead of making this void, because it could have worked on a line like this if you made it a void return type, instead of doing it that way, we're going to have it return the cout right back, the OStream right back. It could have been any OStream. So we're just going to call it OS, not cout, because it could have been something else as well. There are plenty of other OStream kinds of things. All right? The reason you give back this kind of type, the type of cout, we're going to eventually return it at the very end. The reason you can do that is because we like chaining calls to the output operator. All right? So we don't just usually make lines that look like this. We don't just say cout C4 semicolon, because it would have worked with void like this. Instead, what we do usually is we say that like a new line, don't we? So that means this must have resulted in something that I could then give more stuff to. That's what needs to, and that's why we do it this way. Okay. What we're going to do, the reason we're going to make it have that particular return type, the same type as the OStream we were given, is because in our implementation, like it's gonna draw the parentheses like this. What we want to have happen when this runs, it prints out the counter and also returns back the cout that we were originally given. Because then this gets turned into cout endl. And then you can keep chaining stuff like that. That's the reason that chaining works, all right? And then also OStreams is more than just cout. The type of files, OF streams, is secretly OStreamable, can be converted implicitly. So that means you could also give a file to your operator and it work just the same, which is nice. And you better believe you can do the exact same thing with cin, like you can make this kind of operation. Like you can read into a counter somehow, like saying cin, fill in this C4 object. If you give meaning to it, and you better believe the types are going to be iStream instead of OStream everywhere. Okay? And again, you want to be able to chain it so that you can do like cin, C4, and C5, something like that. All right, are we ready to see that in code? Because it is a little weird on slides, I would say. Let's watch it work. So this is a very important thing. We're gonna care a lot about this because that just makes it like it's a one-stop shop for telling C++ how to print your particular special object. Okay. So again, cout C4 and a new line. I can print all these things, right? But right now it won't compile because I have not given meaning to that output operator. Again, C++ is going to be very unhelpful and be like, you tried to use operator less than. Here is a list of all the things I know how to output. All the correct types. I know how to print an int. I know how to print a bool, a double, blah, blah, blah. I do not know how to print a counter. Right? Usually when you see this kind of horrible error message, you scroll up to the very tippy top and then it says something slightly useful. There it is. Like, this was, it just went away, but it said counter. It's like, I didn't know how to do something with a counter. And that's the secret. All right. So we want this to turn into a call to this operator less than with cout and C4. And then it'll get chained in with endl after that's all done because it will return back cout and like use these kinds of parentheses. Yeah. And that's what is going to happen, like implicitly. And so now let's finally make that operator less than. Whee! So scrolling up, it's a mouthful, I know, but you'll get used to it. So it's called operator less than. We're calling it in this way. We're taking, let's split screen this way maybe. We are taking two things when we call it, right? It's going to be given, it's going to be given cout first. So we need to take the type of cout first, which is an OStream, and it could have been a file as well, so we'll just call it OS, or whatever OStream we were given. And then we're taking our counter. That's always the second thing to the output operator. So then we'll take our counter as a const reference, because we're good programmers. Const counter C that we were given. And then the return type is also going to be an OStream reference. Give back the same exact outputable thing that you were given. For example, give back cout all over again, so that now when this results in cout, you can give endl to it right after. That's how that can work. That's why we do it. So, all right, Now it's a two-step process then. The first step is use this O stream, shove stuff that it knows how to print into it using the counter C that you were given, right? So that the goal is now to print to OS however you want. Because you could have been given a file. It's not set in stone that you're given C out, all right? You want, so I say, hey, OS, whatever you were, you could have been C out. Here's how I want to print my counters. Like I'll give it count, colon space, and like c.get count, something like that. It's a pretty way to print a counter. You could make it fancy, all right? But like, let's say that's how I want to print my counters, count. And you do have to be very careful about this. This is a very common error I see in CSCI 41 is saying C out here. Because what if I were given a file? Now I'm shoving stuff into the screen rather than the file. Like you got to give it to whatever O stream you were given. Could have been a file, could have been C out. And then always remember to return. Remember to always return OS at the end. Return OS. Because that allows you to chain these output operators. Now it sees something tangible after this has resulted in C out all over again. And then it can give end L to C out and more things after that too. Potentially. I think, yeah, that's the long-winded explanation. Now it will be happy. So yeah, that's a pretty way to print a counter, and you can imagine for fancier types, like this is very nice. Like I don't want to have to like copy and paste a bunch of code to do this. Like I can just give the thing now to see out, and it'll just jump up here. Know how to print it. Are there any questions about the output operator? It's a useful one to study. All right, I think we made it. So yeah, much less hectic of a day after the first day. So that's the end of these sets of slides. This first little set of slides about object-oriented programming. There's more where that came from, but that's where I want to stop for the day. And like I said before, we have you're supposed to take a break in this class because we have very long class times. And what I want to do for every day but the first day now is just if I have something to give you, I'm going to give it to you right after a lecture, and then I can stop talking and you guys can take your break whenever. Okay? That's how that'll work. So I want to release now Lab 0 and show you how to get it and submit it and do all that fun stuff. All right, so I've released the lab. It will be due August 22nd at 5 p.m. for most of us. Oh man, I have to set up this new thing. Where did they? Oh, there it is. Cool. There's the calendar. So 22nd is the Friday, so it's going to be due in a week and a day. And here is the write-up. So there will always be a write-up for our labs. And here's what I want. All right, so you'll just read it. Please read it yourself. But let me show you how to get the lab. It's going to all be on the class server, and we'll go from there. Okay, so this is just a simple first lab to make sure we're all on the same page. We'll talk about just object-oriented stuff and operator overloading kind of stuff. So, okay, there's two parts. The first part, well, first we have to get the code itself. I always give you some starter code for your labs. And so once you get on the class server, there's a command to get your starter code. All right, so how do I want to do that? Oh, I'm just going to make a new window. So I'm going to get on the class server real quick as my test student. You can do it on PuTTY, however you want. And then let me make sure I'm in a blank slate. No, of course I'm not. I guess I kind of did this last time, didn't I, though? So let me get rid of everything in this directory, just in case yours is empty. Boop. So the very first step, because you get plopped into your home folder when you get on the class server, the very first step is go where you want to go to do your lab. All right? I don't know how you want to organize your files. You can do it all in your home folder. That's fine. But maybe you want to do your labs in a labs folder. The way to make a folder is make dir. Dir is directory, same as folder. Synonyms. So I can be make dir labs. And so now there's that folder that exists. And then you can go cd inside of that. And so now this is my directory that I'm in right now, and it's empty. So get to where you want to be, and then you run this cute little command that I made for us called gimme. You say gimme name of the lab, lab00, at sign the name of the class, CSCI 41. You hit enter. And what that does is it creates a new folder inside of the folder where you were. So there's a folder called lab00, and you go cd in that. And then you see all these files. Look at them. Beautiful. And that's most of your lab. You'll be working on those. All right. There's two parts. There's the first part is use these files. And then the second part is, let's see here, make a Hello World program. All right, so let's do that one first. So the very first step, just to make sure we're all on the same page, everything's working on the server, just make a very simple Hello World program, and I will give you credit for it, for part of your lab. All right, so just write a simple Hello World program with, make it be called exactly hello.cpp. So you're making a file that does not exist yet in the same folder. So make a brand new file. Let me do it in Nano just to make sure we're all on the same page. Please do Vim Tutor so you can do Vim, but let me do it in Nano just to make it clear. So I'll say nano space, the name of the file I'd like to edit. I will have to make a file. The file names are very important. So I got to make a file called hello.cpp. All right, and a file called hello.cpp. Make a program that prints exactly hello world, I am ready for CSCI 41, new line. Okay, so let me do most of that as fast as humanly possible because this is beside the point. Let me mess up. So I said hello world, but I was supposed to say hello world, I'm ready for CSCI 41. Yeah, but I gave the new line. And then return 0. So that's my program. It's good enough for now. And then it's Control X to save and quit. Even on a Mac, Control not Command. And so you say Y for yes, I want to save. I want to keep the file name that I had there. Hit enter. And now I've made that hello.cpp file. Look at it. Beautiful. I can say nano again if I need to change things. Use the arrow keys to move around. But definitely do Vim Tutor. So you can do it in Vim instead, because Vim is cooler. Cool. So yeah, now I've got hello.cpp. You want to test it with the g++ command. G++ compiles and runs. Or just compiles, sorry. And then you run it later. You say g++, that might be hard for you to see in the back, so let me scroll up like that. G++, name of the file, hello.cpp, -o, what you would like it to be called. So I'll call it hello. And that makes, if it compiles at least, it makes a new file that is runnable, /hello, hit enter. Ta-da, there's that program. All right. And yeah, so that's the first part of the lab. Does that make enough sense?
Yeah.
That's what you're doing, just to make sure it all is happy. And then you're going to work on the real parts of the lab, okay? But you are getting credit for the hello world, a little bit. The next part of your lab is to work with these other files, the ones about boxes. All right, so I've got a box drawing library, essentially. That's what's going on, okay? So I've got box.h and box.cpp that describe a box class. And the box class represents a box on the screen, eventually, at least, using a certain character to draw the box. So it could be stars, could be dollar signs, could be anything. Single characters, though. And that is what you're going to implement. Those two files. So box.h looks like this. You've got all these things, public and private. So this is what a box is. A box has a width, because it's same size, width and height is the same. And then it has a character that is the character you would like to draw that box with. Could be a star, could be a plus sign, could be a dollar sign, whatever. And you got all these other things. You've got a constructor. To set the width and the box drawing character, you have to set them somehow. I've got some default values. You've got get me the width, get me the box char, set the box character, drawing character to a different one. Maybe it was plus, now it's a dollar sign or something. I've got a plus equals operator that's supposed to increment the width by some offset that you give. I've got a minus equals operator as a function, it's a friend though, that will decrease the width by an offset. So just getting you practice with all the different ways that you could have made an operator, like as a method, as a function. And then of course we have an output operator that you better believe you're going to implement to actually print that box to your O stream that you were trying to print to. Okay, that's how that works. So that's the header file, and you're going to use all that stuff and implement all the methods and the functions from that file in the corresponding implementation file. Does that process make enough sense? That's what's going to happen. And then you should probably I've given you some files to make sure that things worked. Okay, I've given you a helpful little runbox CVP file that you're not going to be turning in. You can edit that as much as possible, but right now what it does is it tries to use your library just in a simple way. So like enter a width user, enter a character user. It builds your box with that width and that character, and it calls the output operator. Like just those are the key parts of that box class, right? Just making sure that those at least work. And then you can like print out other things, like call other methods and operators to make sure that they're doing the right thing still. But this is just for you. This file is just for you. That you can compile it with your library after you've made it to make sure it's doing the right thing. So for example, like if you were to run that with a width of 8 and a $, like what the output that you should see is this. Okay, that's how that should work. And yeah, to compile this runbox program with your library, you got to give both the implementation files. You say G++, give the runbox.cpp as well as the box.cpp. Remember that the header file is unnecessary because it's being copied and pasted every time you do the include. That's how that works. And I think that's that one. So this runbox file is just for you. You're not going to turn it in. It's just to help you get the implementation working. Does that make enough sense so far? Because there's one more file with another main function, another one that you could compile with the library, and that one you are going to turn in. That one has real tests. Okay, that's what I'll grade you on. All right. The next one is it's another file with a main function. So instead of running it with a runbox.cpp, you can give it the testbox.cpp with the library implementation again. And this one has testbox. This one includes the library and also has assert true, and then has all these tests. All right, to like make sure an empty box prints nothing. A box of size 1 and a $sign prints a single $sign and a new line. A box of size 3 with a % sign as the character prints 3% sign new line, 3% sign new line, 3% sign new line. Yeah, those are the real tests that I'm gonna grade you on. All right, and so there's plenty more where that came from. There's like this one is calling the set box char to make sure it changed properly, then printing something. This one is trying to use the operators in the right way, stuff like that. But those are tests. And to run a test on something that prints stuff, I'm not giving the output operator to see out. Because I need the stuff that you're emitting. I need the characters that you're trying to print. And so to test an output operator, I'm using a type called a string stream, which you might want to look more into. The whole point of a string stream is it's like a temporary string that you can build up with output operators. It understands that. So it's technically no stream in a way. So you can give your box to the string stream, and it has a little method called .stir inside of it that gets out the string you've put into it. And that's how I'm testing. Like test that string that you built in, that you put into the string stream object holds the right stuff that would have been printed had we given the box to see out instead. Okay? That's how that's working. So it's like a programmatic see out so I can check things. And you'll want to do that when I have you make your own tests. All right? But the first step is just make sure my current tests pass because they're fancier than the runbox program if you didn't like add extra things to it. So definitely get these to pass first. And then you're ready to continue. But does the setup make enough sense? So all these tests are like make a box, do something to the box, try to print the box to a string stream so you can look at the string inside of that box, that thing that would have been printed. Yeah. So of course I'll be here to help and explain things further, but that's the gist of it at least. And so you'll get all those to work. So the tests are already running in the main function. And your job, after all that, is to write, please, 6 more tests to test any weird, wild scenario that you would like to test. All right? Hopefully it's something different than what I've given here. But come up with some odd scenarios and write, please, 6 more tests that call assert true, because I consider every assert true call to be one test. So that will print right passed or failed up here. That's assert true. So I'd like you to please write 6 more tests in the same kind of style, like make a function per test kind of thing. And then you're ready to go. All right. Then you're ready to turn things in when you're finally done. I think that's all that I wanted to say. There's a look at the documentation page for StringStream if you need to. I can also explain it further during office hours or after class. But yeah, 6 tests after the current one. So we should see, like my auto grader is going to be looking for 1, 2, 3, 4, 5 plus 6, 11 passed in the output. All right. That's what it's going to try to find. So yeah, I think that is more or less the lab, at least the logistics of it. Are there any questions about what you are being asked to do? All right, so now the final question is, how do you turn in your lab? And so here's how you do it. All right, I've made a cute little turn in command that works in this way. You say turn in space, name of the lab, @ name of the class, just like when you did gimme, and then you space separate all of the files you would like to turn in. All right, so you are not, first of all, this is always like a template of all the files you're going to want to turn in later. Notice how I'm not turning in box.h. When I don't tell you to turn in a header file, that means I'm using the original header file when I grade you. So don't add things to box.h, okay? That's important. Because then the autograder is going to get confused. Like, what are you talking about? I'm using this default one. So even if you were to add box.h here accidentally, I would still be using the original one, all right? It's smarter than that. So, okay, that's the secret. So those are the files that you're eventually going to want to turn in. Those are all the ones that I need from you for your lab eventually. I just encourage you to turn them all in at once anyway. That's fine. Even if you didn't implement anything, it's still okay. So I did not touch any of the implementation of the box.cpp, but I'm still going to turn it just to show you that you could. So I say turn in name of the lab @ name of the class, lab00 at CSCI 41. And then I'm going to space separate all the things I want to turn in. So like box.cpp, testbox.cpp, does not have any new tests in it. And then finally hello.cpp, which I implemented in a Hello World program, but it was wrong because I forgot to add some words. Okay, that's my long line. And then you hit enter. And then in theory, it all starts working. So submitted successfully. You can always press Control-C to get out of this and eventually look at your grade later. But I encourage you to just stick around because it shouldn't be too long unless my data science students just all turn something in. But yeah, it's like finished. You can use view grades, blah, blah, blah. Uploading your grade to the class website, done. In theory, there are no error messages. Let me know if there is one. And then it's like auto grading is complete. Please press Control-C to get back to the submission program. Same on a Mac, Control, not Command. Control-C gets you back to your terminal. All right, so we just turned something in. It got graded. And the way I want you to look at your grade is through the class website. All right, it's copying it there. It's the prettiest way to look at your grade. So I encourage you to go there. So let me show you that way first. So I submitted as my test student. So you click on auto grader grades, and it's like, oh, there'll only be one for you so far, but like lab00 at CSCI 41, click. And when you resubmit, you can refresh this page if you're already on it. But look at it. It's like, okay. It's color coded. So I scored 0 out of 35 because I did nothing right. The Hello World program was wrong, and here's why. Nice, pretty colors, right? It's saying the minus and the plus over here, by the way, those are not part of your output. It's just trying to say, it's called a diff. It's telling that if you were to subtract this line of your output and add in this line, it would have been correct. So it's like your output, expected output on the left and right. And so it's trying to say, like, you forgot all of this. Does that make sense, how you read that? So nice color coded. Try to check it on the class website if you can. And then for the rest, it's just like, this did not compile. And here was the compiler error message. It was a linker error because like the main function existed. All the things were declared in the header file, but you didn't actually implement anything yet. Like, I don't know how to make a box. I don't have the constructor implementation yet. And that's a problem. So yeah, that also gave me a 0 for that part. But yeah, that's what it's going to look like. And there's also a way to check your grades just quickly on the terminal. I made a view grades command, view dash grades. You hit enter, and it's like, which one do you want to look at? There will only be one option for you since you only turned one thing in so far. And these are just like numbers to say which option you want. We're going to want, the most recent is going to be option 0. So we're going to say option 0. I'll say 0, hit enter. And I can use the arrow keys to scroll through a textual representation of that grade. All right, so again, this is what was supposed to happen, including the new line. This is what you gave. Sorry, this is what was supposed to happen. This is what you gave. And then the same for the others. So you press Q to get back to the terminal. Out of that. It's better to use the class website, I would say. Please do that one because it's color-coded. It's easier to see things. It's highlighting stuff. So yeah, that's more or less the lab. It will auto-grade, and I have to manually transmit that grade from the class server to Canvas, and I'm not going to do that every day. So it's like you can see your grade on the class website. That's what it will be on Canvas if you turn it in before the due date. All right. Eventually, that grade will turn up on Canvas. But yeah, just make sure that you're always checking your grade, because like maybe you thought you did something right. The autograder is very picky. Like if you forgot a space, it's giving you a 0 on the Hello World program. Okay, so just keep that in mind. That's important. So remember to check your grade. That's on you. And you are allowed to turn in your assignments as many times as you would like, hopefully within reason, right? You can look at the errors. You should be able to compile and run on your own end before you need to turn things in. But if you got something wrong, you can resubmit as much as you want before the due date. And the last submission becomes your grade. All right? Does that make sense? Last submission becomes your grade, which means the very last time you submit to the autograder, submit every single file. Because if you submitted just Hello World program before, and then you submit just these as your last one, it forgot the Hello World program. You got to give them all at once, right? The last submission in total is your grade. It's not remembering anything else from before. And yeah, that's more or less everything I wanted to say. And that is your first lab. Of course, that is lab 0 because this is computer science. Any questions about that? All right, I have talked enough for the day. The rest of the time is all yours to ask questions and work.